Hello, I'm Robert Reiner, Director of Marketing for Ampere Computing, and I'm here at ARM TechCon 2018. I'm going to be showcasing Kubernetes container orchestration running on our eMAG processor. So I'll step over to where the cluster is running. Kubernetes is a key application for cloud and hyperscale data centers and an important part of our ecosystem. We deployed Kubernetes without modification, illustrating the maturity of both eMAG and our ecosystem. Now, one of the key features of Kubernetes, and we'll take a look at our block diagram of our cluster running here, is that it can scale application workloads both within nodes and across nodes. So looking at our cluster here, what we have is a 3-node cluster. It's comprised of a master node and 2 slave nodes. And the slave nodes are running containerized Oracle Linux, MySQL, Nginx, and WordPress. And as I said, one of the things that Kubernetes is really good at is scaling applications very quickly and efficiently within nodes and across nodes as required. So this is what we're going to demo in our Kubernetes cluster. So let's take a look at the cluster GUI. We'll start by looking at the nodes. As you can see, we have 2 slave nodes, as I showed in the block diagram, along with a master node. And if we take a closer look at one of the slave nodes, we can look at the resource allocation. So right now, there's not a lot of activity. We have 16 CPU cores allocated for this node. Right now, we're using just about a half of a CPU core. It's only running 4 pods, and it can run up to 110 pods. And the slave node has a capacity, memory capacity up to about 100 gig. So let's look at the status dashboard for Kubernetes. So there's basically 3 charts that give the status. The first is deployments. So the deployments represents the API object that's managing the replicated applications. The replica sets are the replication controllers for the applications that are replicated. And both the replica sets are running 3 different instances, as are the deployments. That corresponds to 1 instance per application. So we have 1 for Nginx, 1 for MySQL, and 1 for WordPress. The pods you can think of as each pod is a set of running containers. So we're using Docker containers, and for simplicity, we're mapping 1 container per pod. So for every application, we're running an application on 1 pod. And you can see, currently we have 3 pods running. So there's 1 for Nginx, 1 for MySQL, and 1 for WordPress. What we're going to demonstrate now is scaling, so we'll increase the number of instances running for one of the applications. So we'll go to Nginx under deployments, and you'll see scale here. And right now we're only running 1, so let's scale that up to 50. So I'm going to type in 50 and hit OK. And let's take a look at the status dashboard. And we can see that for deployments, 33% or 1/3 are pending, and that corresponds to the Nginx deployment or for the API object. Replica sets, similarly, we have 1/3 pending. That means that there's activity with our Nginx replication. And if we look at the pods, we scaled, as you recall, we scaled from 1 to 50 Nginx pods. So we have 3 running, which is what we had before, and the pending activity are the 49 additional instances, which is occurring right now. In fact, we'll do a refresh and see how it's doing. And it looks like it's completed. As I said, Kubernetes scales applications very quickly and efficiently. So we've got 50 additional, we've scaled up to 50 applications or instances for Nginx in the time that we've been talking. So let's take a look at Nginx quickly and see where those applications got scaled to, and we can see that it's peppered across slave nodes 1 and 2, which illustrates Kubernetes' ability to do load balancing. So it does it very effectively. It looks like it's roughly even, and we can look a little closer at that when we look at one of our slave nodes. We'll go back and look at the resource allocation, and we can see, first of all, that we have 28 pods now running. So it's roughly scaled 50% on each of the slave nodes, and we now have a lot more activity with the CPUs. So we're getting, so basically a little over 3 CPUs are now active, CPU cores are now active based on the increased activity. We have some additional memory allocation as well. So the one last thing I'd like to show is a containerized application running within the node. So we'll use Nginx to connect to everyone's favorite website, amperecomputing.com. So this is a local copy of our website that's running on the Kubernetes cluster. In summary, Kubernetes is a key application for hyperscale and cloud data centers, an important part of our ecosystem, and we deployed it without modification. Thank you.